Man, those fractional indices are really out in force today. Today we're talking about fractional indices and how you can deal with them. I'll show you how you can break them up so you can simplify them. I'll go through 4 fast examples of how to turn them from surd form into fractional indices forms, and then I'll go through 3 examples of how you can simplify them. So I hope you enjoy the video. Let's get going. All right, I'm sure you probably already know what a rational or a fractional indice looks like, and it looks like this. It's got a base, in this case 7, and a fractional index 2/3. Another example might be this one, 5 to the power of 6/2. Or one more, 9 to the power of 1/2. Now we're going to see how we deal with these pesky fractional indices because we don't like them. We like to have simple numbers, so let's get going. The first main point of fractional indices is to know what this half means. Now you've probably seen this before. What it actually means is the second root of 5. It's got a little 2 here. Now, you've seen this many times before, except usually we don't have the 2 because we don't write the 2 when we have the second root of a number. So 5 to the power of 1/2 is actually the square root of 5. Now let's take it a little bit further. You've got 5 to the power of 1/3. So 5 to the power of 1/3, we transform this into the cube root of 5, or the third root of 5. And once more, 5 to the power of 1/4 is actually the fourth root of 5. So all of these here are based on fractional indices like this, and this is where the denominator is a number. So our little rule for this is the base to the power of 1/n is the nth root of the base, or the a. Okay, this is our little rule here. Now let's talk about the numerator here, this m. I've got a to the m over n. So what does that mean? Well, using our index laws, we know that we can break these two up. M over n means that we can bring the m to the outside of the brackets and have 1 over n on the inside of the brackets. And if we were to use our index laws, we'd multiply these together and we'd end up getting m over n. So we're just going backwards and reversing the process here. So what does that mean for our numbers? It means that we can square root or nth root the inside number, or the base, and then we can put it to the power of m. So let's go through an example and see how this works. So 8 to the power of 2/3. Okay, so we're going to break the numerator and the denominator up. We're going to put the numerator on the outside, and we're just going to leave the denominator, or 1/3, on the inside of the brackets here. So we've got 8 to the power of 1/3, and once we've found the value of this, then we'll square it. So we can find 8 to the power of 1/3. That's actually the cube root of 8. You might not need to write this step, but I'm writing it here for clarity. So the cube root of 8 is 2. And then once we've got 2, we can square that. So our answer would be 4. So this might look a little bit complicated. 8 to the 2/3 is actually 4. Now we split this by putting the numerator outside the brackets. We can also put the 1 over n outside the brackets and split it this way if we want to. So a to the power of m to the power of 1 on n, the denominator. So that means that what we'll have is the power on the inside, and then after we've found the inside, then we will find the nth root. So let's use the same example again. 8 to the power of 2/3. This time we're going to split it so that the 1/3 is on the outside of the brackets and the squared is on the inside of the brackets. So now we have 8 squared. 8 squared is 64. And now we need to find the cube root of 64. And the cube root of 64 is 4. So you can see we've done it 2 ways and we've got the same result both ways. Now, secret squirrel tip, this one is usually easier. Why is that? Because the number that we find inside the brackets, if we find the cube root or the fourth root or whatever it is, we'll usually end up getting smaller numbers and then we square that. Whereas if we do it this way, we might get 8 to the power of 5. That might be quite painful to do before we find the nth root. So I highly recommend do this way first and put the 1 on 3 on the inside and put the numerator on the outside. Let's go through some fast examples. We want to write this surd form into a fractional index form. So we know that the square root of 15 is actually 15 to the half. Easy. B, square root of 7x to the power of 5. Using our surd laws, we can break that up into 2 bits. So square root of 7 and square root of x to the power of 5. We know the square root of 7 is just 7 to the power of 1/2, and the x to the 5/2. This square root becomes the fractional part, the denominator, 5/2. Part C, 3 times the fourth root of x to the power of 7. This fourth root only applies to the x, doesn't apply to the 3 over here. So it's 3 times x to the 4/7. And our last example here, 10 square root of 10. All right, 10 is actually 10 to the power of 1. And the square root of 10 is 10 to the power of 1/2. Using our index laws, we know we can add these two indices together if our bases are the same. So our base is the same at the moment. So that means we've got 10 to the power of 1 plus a half. Adding fractions together, that's actually 2 on 2 plus another half gives us 10 to the 3 over 2. Let's go the other way now. We're going to go from fractional indices and we're going to put them into surd form. 16 to the half equals the square root of 16, as we've spoken about before, and square root of 16 is 4. That was easy. Part B, 16 to the quarter. So remember, looking at this n here, n is 4, which means that's going to be the fourth root of 16. So the fourth root of 16 is actually 2, because 2 to the power of 4 equals 16. Okay, tricky one. We have a negative indice here. Hopefully you remember your negative indice laws. So to get rid of this negative index, what we do is we bring this whole lot underneath the divide sign, underneath the vinculum, and make it a positive power. So now it's 1 over 27 to the power of 1/3. 1/3 is actually cube root. So we can say 1 over the cube root of 27, and the cube root of 27 is 3, so we get 1 over 3. Okay, that's it. I hope you enjoyed this video today. Now make sure you go out and destroy those pesky fractional indices. Man, those fractional indices are really starting to get annoying. What is it with all these fractional indices today? They are so annoying. Those fractional indices, they're so annoying.